Hey guys, today I'm going to teach you how to represent integers on a number line. By the end of this lesson, you should be able to model those integer operations on a number line, recognize absolute value and numbers opposites and zero pairs. We'll get into all that later on. So go ahead and take out your binder, turn to the math section, and get ready to take some notes. So let's get started with what we already know about number lines. First of all, this is an example of a horizontal number line. This is represented from -10 to 10, but they can go on from infinity. We know a few things about number lines already. We know that whenever we look at counting numbers, if I was going to count to 5, you would start at 0. So I'm going to take little me. You always start at 0 and you count. If I was counting up to 5, you might have counted 1, 2, 3, 4, 5. And then whenever you plot a point on a number line, you plot it right on it. So this is probably something that you learned a long time ago. Maybe even in first grade, you started learning about number lines and plotting on number lines. But the same can be true about negative numbers. So let's say I want to represent -5. I could take little me, and when I see a minus or a negative, I'm just going to go the other way. I'm always thinking about that as the opposite. So since it's a -5, I'm going to start at 0 and go 1, 2, 3, 4, 5 back. It's the same process. You put a dot or a point right on the number line. So everything that you know about horizontal number lines also applies to vertical number lines. So this is a vertical number line because it goes straight up and down. Remember, horizontal is like looking out at the horizon. It's left to right. And then vertical is, remember how high you can jump in basketball is like getting your vertical up. That's how high you can go up and down. So the same thing works. Up is positive and down is negative. If I wanted to count to +5, I would go starting at 0 up to 1, 2, 3, 4, 5. And then you also plot a point on the number line at 5. You could do the same thing for -5. So instead of going side to side, we're just going down. So I'm going to start at 0 and go 1, 2, 3, 4, 5. So when you see a negative, that means go the other way. So let's look at two examples. This is just a review of what you already know about number lines. I'm just going to show you with this little guy. So whenever you see a problem like 2 plus 6, you start at the first number. So I'll start at 2. And it says +6. So since it's plus, I'm just going to keep going the same direction I'm already going. 1, 2, 3, 4, 5, 6. Now I'm at 8. So I went from 2 plus 6 is 1, 2, 3, 4, 5, 6. Now I'm at 8. So that's why 2 plus 6 equals 8. The same works for a subtraction problem. You look at your first number. I have a 9. So I'm going to start out by putting my little guy on the 9. But what we see next is a minus. And when we see a minus, what I want you to get in the habit of thinking is when you see a minus, that means turn around. So we're going to switch direction. And then it says 5. So go back 5. So we're going to take our little guy and go 1, 2, 3, 4, 5. That's how we get 4. So again, if you were going to look at this with representing it with like a model, you would start at 9 and it's go back 5. So that could be what this example looks like. So that was all review of stuff you've already known. Let's go ahead and get into the new stuff. So this is the integers on a number line in 7th grade. So we learned in the last lesson what integers are. They are positive or negative whole numbers and can be represented with a number line model. So integers are types of rational numbers. So we're going to just mark a point at both 5 and -5 on the number line below. So we've already done this, so you can try it on your own. You can pause if you need to, but I'm going to go ahead and just know that I'm going to put a spot at 5. I'm just going to mark my point at 5, and I mark it right on the number line, not above it, not below it, right on it. So I'm at 5 and -5. Now I want you to look at this and see what you notice to be the difference. What's the difference between these two things? Well, the negative sign makes this the same place, just on the opposite side of the number line. So that -5 just means that it's 5 back this way, and this +5 just means that it's 5 forward this way. So the same distance apart from 0, just on opposite sides of the number line. So this leads me into a new vocab word called absolute value. So absolute value is really important for us because the absolute value of a number is the distance away from the 0 on the number line. So basically just how far away from 0 is it? So the absolute value of -5 is the distance between 0 and -5. So there's 5 between it. So it would be 5. The distance between 0 and 5 is 5. So absolute value just means the distance away from 0. This means that no matter how you slice it, the positive version of the number is the absolute value of the number. So for example, if I put an absolute value, this is what the absolute value symbols are. basically two little bars, and it squishes out the negative. So this absolute value of -5 is just 5. And there's some more examples here. It says determine the absolute value, then mark each point on the number line. So the absolute value of every number is always going to be positive. So if you have a negative in there, it'll make it positive. If it's a positive in there, it'll stay positive because it's distance, and distance cannot be negative. You can't go, I'm not going to say I drove from here to Peking and drove negative 19 miles. It's 19 miles, even if I'm going backwards. So looking at A, it says the absolute value of -8. Remember, these little bars just squish out that negative, so that would just be 8. And I'm going to go ahead and plot that on the number line. So that's 8, and since this is point A, I'm going to go ahead and mark it as A above it. For B, it says absolute value of -1. That turns into a +1. Being 1 away to the left is the same as being 1 away to the right. So the absolute value is always going to be positive, so we're only going to keep that +1. So that's B. And I want you to go ahead now and pause the video. Try to find the absolute value of C, D, and E. It's pretty simple. You're just turning it, if it's negative, positive. And if it's positive, you're leaving it the same. And then plot it on the number line. Press play whenever you think you have it. Okay, so let's look at C. It says the absolute value of 3. That's still just 3. That means that it's 3 away from 0. This is point C. For D, it says -4.5. That's going to be +4.5. And this might be a little bit trickier, but you're just going between 4 and 5. So 4.5 is between 4 and 5. So that's point D. And then E says 6. Absolute value of 6, that's still just going to be 6. So I'll mark that on my number line. Pretty easy so far, right? So the two key words that you need to know are absolute value and opposite. Absolute value is the distance away from 0. That's always going to be positive. Opposite just means what's the opposite version of the number. So for example, -6's absolute value is the absolute value of -6, which is just 6. The opposite of -6 is 6. If I look at 18, the absolute value of 18 is still 18. But the opposite of 18 is -18. It's the negative version of that number. You can also call this its zero pair because -18 and 18 together make 0. If you owe me $18 and I give you $18, now you owe me 0. So you can hear it be called a zero pair or an opposite. Go ahead and fill out the rest of this chart by yourself and then press play whenever you're ready to go over it. Okay, so you should have just tried these next 3 in the boxes, but I'm going to go ahead and do those for you now. So absolute value of 34 is still 34, and its opposite is -34. The absolute value of -67 is still just a regular 67. It's 67 away on either side of the number line. That's the absolute value. And the opposite of -67 is a +67. The absolute value of -128 is a +128. And then the opposite of that is a +128. So the question that's checking in here says, using the table to the left, determine which two columns can be added to get a sum of 0. So it's saying, do I add the number with its absolute value or with its opposite to get 0? So think back about our definition. An opposite is a zero pair. So 34 and -34 make 0. -67 and 67 make 0. So what I want you to remember is that a number and its opposite will always add to equal 0. So I wrote the number and its opposite will result in a sum of 0. I used the word sum. Recall that sum means the answer to an addition problem. So for the next section, we're going to think back to what we started out looking at, which is modeling the problems on number lines. So we're going to begin the model at 0 is what it says. So I'm actually going to think about it like this. You can begin at 0, but you're going to end up beginning with this number anyway. So I always start by plotting at that number. You can always think about it like beginning at 0 and going back 1, but I'm just going to go ahead and I'm going to ignore that begin at 0, and I'm going to begin with the first number. So I'm going to begin at -1. I'm going to go ahead and pull up little Mr. C to help solve this problem. I'm going to start at -1, and remember, we read left to right. So whenever we look at an expression or an equation, I'm always going to see a plus sign and keep going left to right. So I'm naturally going to go left to right. So I'm starting at -1, facing the right. So as long as I see a plus, that means keep going. So it says go up 4. So 1, 2, 3, 4. So now I'm landing at 3. So one way to model this would be to draw your point at -1, and then since it says +4, I'm going to go forward 4. So that's the direction that I went. For number 2, it says 1 plus -4. So now we're starting to get into some integer operations. We're just going to model it on the number line. So we start with the first number, and since it says 1, we're going to start at 1. And it says plus, so we're going to put our little guy on there. Remember, we always go left to right, so we're facing the right. But then you see a negative. And remember, when we see a negative or a minus, that means turn around. So as soon as you see a minus, you turn the other way. And then go 4. So 1, 2, 3, 4. So I landed at -3. So the way to model this would be back 4. Go ahead and try number 3 by yourself, and then press play whenever you're ready to check. Okay, so you should have tried this. What I want you to think about always is whenever you see this first number, that means start there. So begin at -1. So I'm going to plot my number at -1. I'm going to put little Mr. C on the line. If you have a little guy that you can use to help you do these, go ahead and use that. Get your thing out. Do it. So I'm going to always start reading left to right. So I'm always going to be facing the right. So I'm just reading this equation just a little piece by piece. So start at -1. Keep going. Turn around. So every time I see a negative, that means turn around. So now that I'm facing the other way, I'm going to take my little guy and go 4. 1, 2, 3, 4. So I land at -5. So the way to represent that would be an arrow going back 5. And then that next one's pretty easy. So start at 1. You always start with the first number. And then it says keep going 4. So keep going 1, 2, 3, 4. Now I'm at +5. So I went from 1 to the right 5. So what I want you to look at is any patterns that you notice. I might want to focus on this one and this one. What happened whenever you saw that plus negative? What did you really do whenever you added a negative? Hopefully you can realize that whenever you add a negative, that's basically the same thing as subtracting. So one quick thing that you might already start to notice is that adding a negative is the same thing as subtracting. We'll be practicing this all week, so we'll get more examples of those in the next lesson and then the next one. So don't worry if you don't get it yet. Just go ahead and make sure that you understand that when we model operations, we always start going left to right until we see a minus or a negative, and that means turn around. Okay, so we're almost done here. So this last section, I want you to try by yourself all the way. Try 5 through 10 all by yourself. They get harder as they go, and these are really tricky problems. So this might be your first time looking at anything like this. That's okay. Make your best guess on these. I want you to try, put something down, and then press play whenever you're ready to check. So let's go ahead and go over number 5. It says begin at 1. The first number is always the number that you start at. So I'm going to go ahead and put Mr. C on the 1. Remember, until I tell you otherwise, we're facing left to right. And since it says go back, so 1 minus, anytime I see a minus, that means turn around, go the other way. I have to flip him to go backwards. And then I keep reading it. 1 minus 4 means start at 1 and go back 4. So 1, 2, 3, 4. So I landed at -3. To represent this with an arrow, you would start at 1 and go back 3. So the same thing applies to number 6. It's the same process. You start at that first number, so you start at -1. I'll put little Mr. C on the line at -1. He's facing to the right, but then I see a minus. So if I see a minus or a negative, that means turn around. So I need to face the other way. Now that I'm facing the left, it says go back 4. So I go 1, 2, 3, 4. Now I'm at -5. So I started at -1 and went back 4 to get to -5. A real world problem that might model this problem here would be I owe Chessie $1 and then I owe her $4 more. Now I owe her $5. So this next one is definitely trickier, but it's the same process. Start at -1. So I'm going to put little me on the line at -1. Remember, I'm always facing the right until I see a minus or a negative, which means turn around. And I do. The next thing I see is a minus. That means turn around. So now that I'm facing the right way, I'm going to keep reading my problem. Uh-oh, I see another minus. That means turn around again. So I'm going to take my little guy and I'm going to turn around one more time. And then I'm just going to go 4. So 1, 2, 3, 4. So now I'm at +3. So if I'm going to model this, I just went 3. So whenever you see minus or negative, it means turn around. So you start at the first number, and then we turned around, and then turned around again. That's how we ended up going forward. For number 8, we'll start at 3, and then we're going to put a little guy on the line. It says go back or turn around. So we're going to turn around, and then go 5. So 1, 2, 3, 4, 5. Now I'm at -2. And to model this problem, I would draw an arrow starting at 3, going back to -2. Let's look at number 9. We are almost done, guys. Stay with me. Start at 3. So start at 3. Put your little guy on the number line. Then I see a turn around or a minus. So I'm going to turn my little guy around. Then I see another minus. That means turn around again. So now that I've turned around, it just says go 5. So I'm going to go 1, 2, 3, 4, 5. So I'm at 8. So I went from 3 forward to 8. And then this last one here says start at -3. So I'll put my little guy on the -3. And then it says go back or turn around. When I see a minus or a negative, that means turn around. And then right after that minus, I see a negative, which means turn around. So I'm going to turn around again. And then I will just go 5. So 1, 2, 3, 4, 5. So I landed at +2. So I ended up moving to the right. So this is a preview of what's to come, but maybe if you notice whenever you minus a negative here, here, and here, which direction did we move every time we minused a negative? I think you notice that we are moving to the right. Every time you minus a negative, you're really adding. So in summary, I want you to write down anything you might need to remember from this lesson. I think one important thing that I would write down is that you always start at the number, and then whenever you see a minus or a negative, turn around. If you see a plus, that means just keep moving forward. So that is what I want to remember from this lesson. That's probably the most important thing you can know from today. All right, guys, that's it. If you made it to the end of this video, please put your favorite animal in the comments. Today we went over horizontal and vertical number lines. We reviewed what integers are and what they might look like in operations like subtracting and adding. And now you should be able to model integer operations like adding and subtracting on a number line. So now what you should do is go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye!